In this lesson, we're going to learn about straight line graphs. And by the end of it, you should be able to draw your best fit straight line, determine your y-intercept, determine your gradient, and be able to interpret your gradient and your intercept for the straight line graphs. So the best way to do this is to actually draw a graph. I'm going to start off by simply putting on the title. I'm going to leave out the scale for now, since this is just a rough idea, not really a specific scaled graph. I'm going to draw in my y-axis and my x-axis. Notice that I have the quantity name, the quantity symbol, and the quantity unit on each of my axes. Then I'm going to plot the points using the method I've showed you before, and I'm going to draw my best fit straight line through those points. Now the best fit straight line should be passing through as many points as you can, and you should also try and distribute the points as evenly as you can on either side of it. Now the best way I've found to actually identify the best fit straight line is to change your paper angle, your view of the paper that you're looking at. So if you look at the paper from the edge, alright, you can notice right away what the best fit straight line should look like. So if you look at by the corner of your paper, you should easily be able to identify it. Alright. Next, from there, you will identify 2 points on your graph. Now, this is a sample of what your graph, your best fit straight line, would end up looking like. You're going to try and find the points at which the vertical and horizontal grid lines that cross meets the line. So notice that this point here, the line seems to pass directly through the intersection of the vertical and horizontal grid lines. Similarly for this point. Those are the easiest points to use whenever you have a scale. Now this is not restricted to the points that you plot, as long as the points are on the line. Alright, from there what you do is you simply read off those values as your x1, y1 and as your x2, y2. Then you draw a right angle triangle. Now this is being done on your graph, and you will see that this horizontal line here simply represents the change in your x-axis, and this vertical line here represents your change in your y-axis. When you're determining the gradient is simply the change in your y per unit change in your x. So therefore we are simply going to take the y2 value up here minus the y1 value down here. Then we're going to take the divide that by the x2 value minus the x1 value. From there, you will get the gradient. Now the next important part about the graph is the intercept, the point at which the graph itself, the best fit straight line, cuts the y-axis. Now in this graph here, this is the point at which it cuts the x-axis. And that y-intercept tells us what the y-axis quantity will be if the x-axis quantity was 0. Okay, so from here, once you're finished with that, we'll go into analyzing the gradient. Now remember the equation that we saw before. Gradient is equal to delta y over delta x equal to y2 minus y1 over x2 minus x1. We now have to figure out a unit for this gradient. So what we're going to do is we're going to take the gradient units as being equal to whatever y-axis quantity units we have divided by whatever x-axis quantity units we have. In this case that we was using before, on the top we had a distance measured in meters and we had a time measured in seconds at the bottom here. Notice that at the end of it, when you use algebra, this here is meters per second. In this case, this shows you velocity. Alright? Now, not all graphs will be straight line. Alright? It is very possible that at some point in time you will see different shapes of graphs. Do not try and force all your graphs to look like a straight line. You will end up being wrong. Alright? So, if you have any questions or comments, you can send me a message and I'll get back to you as soon as I can. Thank you.